Chapter 4, Climate Change. So before we delve into climate change, we first talk about ionic compounds. We talked about earlier covalent compounds are when two nonmetals come together, and nonmetals are found on the right side of the periodic table. Well, ionic compounds are when a metal on the left side of the periodic table combines with a nonmetal on the right side of the periodic table. And they form an ionic compound. So that's a giving, which is the metal, and a receiving, which is the nonmetal of electrons. So when a metal gives its electrons away to the nonmetal, it becomes a cation. And when a nonmetal receives an electron from the metal, it turns into an anion. And in more detail here, we know that from the periodic table, sodium has 11 protons, or the atomic number is 11. And when it loses its electron, the sodium becomes Na+, a cation. And where does that electron go? That electron is received by chloride, which is Cl. It receives that electron and becomes chloride ion, an anion. So that makes a good formation of NaCl. What are these charges? Well, if you look at a periodic table, the alkali metal, they all share similar properties and they all have a +1 charge. The second column, which is alkaline earth metal, is a +2 charge. And we have no systematic way for the transition metals, which are located in the middle. So you'll get a reference table on what these possible charges are for the transition metals. And if we look on the right side with nonmetals, the halogens, group 7A, is -1. The chalcogens, group 6A, -2. Well, if you remember, for naming covalent compounds, which are two nonmetals coming together, we use the prefixes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. But for ionic compounds, we don't use prefixes such as mono, di, etc. But we do change the ending of the second element. So for instance, sodium chloride, which is NaCl, the chloride gets the ending IDE. Just like when we were talking about covalent compounds, carbon dioxide, the ide gets the ending. It goes from -ine to ide. So here we have magnesium oxide, MgO, sodium bromide, and we use Roman numerals for the transition metals, the ones in the middle. This one would be called iron 2 oxide, iron 3 oxide, and we'll talk briefly on how we know it's Fe2O3 versus FeO. So the way we do this is the question is asking us, I won't ask you to pause because we haven't talked about this, but the way you do it is you will use a crisscrossing method. And what do I mean? For instance, sodium, which is Na+. We know that because it's a group 1A element. We know Cl is minus. And what is the chemical formula when they come together? Well, you simply crisscross the two numbers. And this becomes Na1Cl1. When the 1 is at the subscript, we can remove it. It's implied that there's 1. So when Na plus and Cl minus come together, you get NaCl as a product. Let's keep going here. Let's try this potassium and fluoride. K plus, we know it's a group 1 element, and F minus, which is a halogen. You crisscross, you get Kf. Let's try this one, aluminum, which is 3+. We know this from the periodic table. And again, Cl minus 1. When you crisscross, this comes out to AlCl3. So you don't have to worry about the minus charge or the plus charge. You just have to worry about the numbers itself. Now, what about something like Ca, which is calcium and sulfide? Ca is 2 plus, S is 2 minus. When you crisscross them, you get Ca2S2. However, you cannot leave them as 2 and 2. You have to simplify them. And the way it gets simplified is you can divide both numbers by 2 to get CaS. So when calcium and sulfide come together, you get CaS. And they're asking for names. So let's try to name some of these now. Sodium chloride, ending IDE. Calcium sulfide, IDE ending. Potassium fluoride, IDE ending for the second element. Aluminum chloride. So again, don't use tri and mono because it's an ionic compound between a metal and a non-metal. So aluminum chloride. And just try this one. This is not telling you the charge, but let's say cobalt 2 plus and Br minus. They'd have to tell you what the state of cobalt is. If these two came together, it would be COBr2, cobalt 2 bromide. We also have polyatomic ions here, and that's when one or more atoms come together to make a polyatomic ion, which has a charge. Ion has a charge. It can be a cation or an anion. So these are the common ones that we want to be familiar with for our class. And we'll use these as we talk further in the class and actually try to name or write the chemical compounds. A little bit more naming. So we've gone to writing the chemical compound. Now we're going to name them. Ion compounds with polyatomic ions, they stay the same. They do not change the suffix. So this is K. We know it's +1. And carbonate, we know it's -2 from the previous chart. And when you crisscross them, you get KCO3, and you have to add a 2 here because the 2 crosses it over. In this case, how do we know it's ammonium bromide? The NH4 is a plus charge. Again, this is a polyatomic ion, and we get this information from the previous table. Bromide is -1. Crisscross them, you get NH4Br. You do not have to put the 1 in the 1 because it's implied. And that's just a little bit briefing on naming ionic compounds and writing chemical formulas. Let's try a few here. We have a bit of time. It says name each of these compounds. Well, the first one is potassium, the K, and NO3 is nitrate. We can try this one, magnesium, Mg2 plus, and the PO4 is a phosphate. So it would be magnesium phosphate. The next question is write the chemical formula. So again, we have to know the name. For instance, magnesium carbonate, Mg 2 plus. We know it's 2 plus because it's from the second column. And carbonate, which is CO3 2 minus. When you crisscross them, you get Mg2CrO3 2. However, we have to reduce. Divide both by 2. So this becomes MgCO3. So maybe you can pause the video now and try some of these on your own. These polyatomic ones are a bit more challenging. So I'll let you guys give it a try.